Right. Guys, now we are going to discuss the answers for the essay paper in the special test paper number 2, right? Okay. So in the first question, in the essay paper, um, the artillery is mounted horizontally as shown in the figure about 125 meters from the ground level. Mass of the artillery without bullet is 400 kilogram, 4000 kilogram, and the mass of the bullet is 200 kilogram. Uh, Two horizontal springs are connected to a fixed support and artillery to reduce the distance that the artillery recoiled when ammunition is released. Bullet released from the artillery when the enemy army arrived. Right. That's a, small description. Right. The first one, the A part. The velocity of a bullet emitting horizontally from the gun is 120 ms minus 1. How long does it takes to fall 125 meters? Right. So guys, this is just the normal projectile motion question, right? So this artillery is projected with the 120 ms minus velocity. So then after that, it is moving in a trajectory pathway, right? So the initial height is 125 meters. So now the question is asking about uh, the time it is taken to reach the ground, right? So normally, let's assume that this apply an equation from vertically downwards of s equal ut plus at squared. Then s equal 125. Now guys, keep in mind that vertical initial velocity should be equal to 0, right? So then we can neglect the u. Okay? Half. Now we are applying the equation vertically downwards. Hence, this a should be substituted as plus 10 t squared, right? So then t squared equal to 25, t equal 5 seconds. What is the horizontal displacement of the bullet? Right. That's mean this one. Distance from the this point into the point where the collide with the ground. So to obtain the horizontal displacement, I am applying this s equal ut. Then is equal r. Now initial horizontal velocity is equal to 120. The time should be 5. Then it should be answer should be the 600 meters. Find the velocity and the direction of the bullet just before the bullet hits the ground. Right. So normally, you know, guys. So just before collide with the ground, let's assume that this is the position where the just before the collide with the ground. At this point, this object consists of vertically velocity component as well as horizontal velocity component. Right. To obtain the resultant velocity, let's assume it as VR. So this is the relevant equation to obtain the VR. Now I think you have familiar with this kind of equation, isn't it? Right. Then VR can be now we have to find the Vx and Vy to obtain the VR. Now already we know that Vx is equal to, we already know the value of Vx, that is 120 ms minus 1. Because guys, keep in mind that the horizontal velocity component of a projectile motion remain constant. So that's why it is directly can be considered as 120. Right. To obtain the Vy, I'm going to apply an equation from vertically downwards. What is the equation? Now we know the times. Then let's apply V equal ut u plus 18. Then u is equal to 0. A mean 10. 5. T mean equal to 5. So the vertical velocity at this point is equal to 50. Right. To obtain the VR or the resultant velocity, we have to substitute for this equation. Then it's 120 square plus 50 square. Right, guys. In this question, you can be able to figure out that this is equal to this one. So this can be further clarify as this 169 over 100. So the root of 169 means 13. Root of the 100 means 10. So the answer should be the 130 m minus 1. So it is very simple question, right? In the B part, when the bullet is released from the gun, it recoil and come to a sudden rest. A mechanism has been established to keep the artillery at rest. Find the velocity at which the gun begins to recoil after the bullet is released. Right. So now they mentioned that this artillery, initially, artillery with the bullet is at rest. Right. So then what happened due to the fire? This bullet is moving 120 ms minus 1 velocity. As a result, you know that the artillery will also move with the v constant the backward direction, right? So let's assume that we don't have any idea about the direction. So let's substitute the velocity as the v, right? So what is the equation or what is the theorem that we need to apply? So obviously, momentum conservation law, right? So if I consider the momentum conservation law, initial momentum, that means just before the fire, is equal to 0. At this point, the mass of the object is equal to 200. So then 200 into 120 plus 4000 into V. We don't have any idea about the V. So let's take this term into the opposite side, then it should be considered as 120 equal into 200 equal 4000 V. So then in the simplification, we can cancel these 4 zeros. Then V equal to 24 over 6 mean 24 over 4 mean is 6. Right. Guys, the meaning of this minus sign, that is, we consider this direction as the positive. So then, if it is mentioned or symbolized as minus, so that's mean this artillery move backward direction relative to the direction of the bullet. If the maximum length that a spring compresses 3 meters, find the deceleration experienced by the artillery. Right. So in this instance, now according to the question, it is mentioned that there are two springs connected to this artillery, right? So this obviously these two springs should be connected in parallel way, right? So according to the theoretical things, guys, let's assume that the spring constant of this spring as k, and the other spring constant is also can be considered as k. So if we consider the equivalent spring constant of these two spring, we can consider that Let's assume that the spring constant of the equivalence spring as K naught. So then we know that K naught can be obtained by adding these two. That is K naught equal to K. Right? So this is the way that we obtain the equivalence resistance, right? Right. Then now due to this, this this spring is compressed up to 3 meters, right? So we can able to represent, right? So in this equation, so in this question, now initially this object having a velocity of 6, isn't it? So now I'm drawing this artillery as a box, right? Right. So and let's assume that the resistive force experienced by this artillery as simple length. Then, if I apply the work energy theorem, so at this moment, what are the mechanical force that we have? That is half mv squared equal to, now at the maximum compression, the velocity instantly becomes the rest, and there's only a kinetic energy. So it's sorry, there's no kinetic energy at this point, only having a elastic potential energy. Thus, let's assume that the frictional force experienced by this object as F, so it should be multiplied by X, right? So unfortunately, this question they didn't mention about the coefficient of friction. Sorry, coefficient of friction, not the coefficient of friction. Spring constant. They didn't mention about the spring constant, so that's why we can't able to obtain the value for F, right? So let's assume that if we able to find the value for F, then we can able to apply the F equal MA, this obtained value. So then we can able to find the deceleration, right? Okay. Now, therefore there's issue in the second part of this question. So just neglect it, right? But just familiar with these applications. Okay. Then let's move on to the C part of this question. In the C part, it was observed that an enemy aircraft moves towards the artillery at a velocity of 100 is in parallel to the ground. The artillery trunk is tilted to 30 degrees to attack the bow aircraft. Ammunition was released towards the aircraft 4 seconds later after initially observing the aircraft at 120 speed. Right. So there's a sentence which is given in, which is bolted because that sentence might be very important when obtaining the answer, right? So what is the meaning of this sentence? This bullet is released from the artillery towards the aircraft 4 seconds later after initially observing the aircraft. Now the velocity of the aircraft is equal to 120, right? So let's assume that this is the initial position. So this is the aircraft and it is moving with 120 speed. Right. So let's assume that this is the time where the observe this aircraft, right? So after 4 seconds, a bullet is released. So at this particular time, that's mean within this 4 seconds, this aircraft should move towards the artillery, right? So let's assume that this is the uh, project. This is the trajectory pathway of this bullet. Uh, so this is the initial velocity, and the angle can be considered as 30 degrees. The bullet is released from the 100 ms minor initial velocity. The bullets collide with the plane at the highest point of the trajectory pathway. Right. So this bullet is collide with the aircraft at the highest point of trajectory pathway. So this is the normal pathway of this bullet. So let's assume that this is the highest point. So at this point, aircraft is collide with the bullet. So that's mean within this time, this is the collision of the bullet and the aircraft. But keep in mind that, guys, the most important thing that when the bullet is released, let's assume that this is the position of the aircraft. I'm taking three points of the aircraft. A mean the position. A mean positions of the aircraft when observing. This is the position of the aircraft when observing the aircraft. When observe the aircraft. Right? So P mean the point of the aircraft, which is this is the position of the aircraft when releasing the bullet. So that's mean the time which is A to B can be considered as 4 seconds, because when the this bullet is released after 4 seconds, after 4 seconds after observing the aircraft. So this is the position of the aircraft where it is noticed, and within this 4 seconds it should be moved forward, isn't it, with the constant velocity of 120. So this should be identified by you. Otherwise, uh, you will face some issue while doing the calculations, right? So let's assume that, guys, the time taken by this aircraft to reach from B to C as T, and that time is also considered as the time taken by the bullet to reach from this position to the highest position, right? So these things should be noticeable, should be noticed, right? Then first one, find the time taken to collide the aircraft and the horizontal displacement of the bullet when collision occurred, right? So they mentioned that this bullet collide with the aircraft at the highest point, right? So first of all, we are asking about the T. Okay, let's apply an equation vertically upward. Now they mentioned that it's the highest point, so we can able to use this equation, isn't it? So V should be 0, U should be equal to 100 sine 30, which should be minus 10 into T. So if I count, take this T, 10T into the other side is converting to positive, equal 100 over half. Then T is equal to 5 seconds, right? Horizontal displacement of the bullet means solution, right? So let's consider this one as the horizontal displacement of this bullet. To obtain the horizontal displacement, I am using this equation. So then S equal to R naught, you mean 100 cos 30 into T. Now we have already find the T. Then 100 plus 30 mean root 3 over 2. 5. This means answer should be the 250 root 3 meters. So that's the horizontal distance of the bullet. Second one, find the horizontal distance from the observer to the aircraft when it's initially observed, right? That means now we already know the R naught, right? Let's assume that, guys, the distance between P and C as x1 and distance between B and A as S naught, right? So we can able to find the S naught. So S1 by applying this equation to aircraft, because we know the time taken to reach from B to C as 5 seconds. So the S1 value should be 120, P should be 5, then it should be substituted as 100 meters. On the other hand, X naught can be obtained by using this equation. S equal to T 120 over 4, it is 140, 480 meters. So the total distance should be 600 plus 480 plus 200 plus 200 into root 3. Right. So however you can able to obtain the answer now. Okay. Then assume that the time taken by the bullet to leave the artillery is 0.1 seconds. Find the force exerted on the artillery bullet due to the bullet release. Okay. Now, guys, due to the releasing of the bullet from the artillery, there's a impulsive force exerted on this artillery, right? So initially, this bullet is at rest, but it is fire with 100 velocity with an inclination of 30 degrees. Right. Then to find the force which is exerted due to this firing of the bullet, we can able to use this equation because P equal momentum difference. So let's consider this direction. So F into T mean 0.1 second. M mean find the force on the artillery. So let's substitute the weight mass of the artillery, that is 400. Velocity should be 6. Initially at rest, so that's why I use 0. Then if equal to 4 into 6, 10 into the power 4. So guys, this is the force. I think you might have a difficult issue while simplification this one, right? Normally, keep in mind that you have to consider these equations, right? Okay, guys, let's move on to the second question of this paper. The diagram shows how a uniform cubic box with a mass of 330 kilogram is placed on a rough horizontal plane, and the force P is applied theta angle to the horizontal surface. The bullet is in static equilibrium phase. Now the bullet is this box is in the static equilibrium state. Okay, right. A student state that the friction force on the surface is self-adjusting. Right? Is this statement true? Right. So guys, what is the meaning of self-adjusting? That means if we increase the external force, ultimately the friction force also getting increased. That's the mean self adjusting, right? That means if we change a particular force, what happened? Accordingly, the friction force is also increased. So we know that static friction is self-adjusting force, because when we increase the external force, static friction force is also increased. So you might remember this equation, this graph. Let's assume this is the external force and this is the friction. If I plot it, so this is this slide. See, when the P is increased gradually, F also is getting increased. That's mean this statement is correct. This statement is correct. Second one. Copy the above figure and indicate the force acting on it. Right. So this is the object. This is the applying force. So we have to mark the weight of this object. It is 300, and normal reaction which is exerted by the ground. And now due to this exerting this force, this box tends to move right side. So there, as a result, the friction force should be exerted in opposite direction. Right? In the third part of this question, find the value of P by considering that theta is equal to 45 degrees. Assume that the static frictional coefficient of static friction between the box and the plane is 0.5, right? Now we have to consider the static coefficient of static friction as 0.5, right? Okay, guys. Now, first of all, now they have given that this angle as the 45 degrees. So if I do resolve these forces, so I can able to resolve this P into the horizontal as the P cos 45. In upward direction, it can be considered as P sin 45. This should be 100. This one the R. This is obviously equal to, right? So, however, we have to assume that this box is at static friction, or that this box is at equilibrium state. So that's mean if it is equilibrium state, the forces, the resultant forces exerted in vertical direction is equal to 0. On the other hand, the forces which is exerting horizontal direction should be equal to 0. Right? So if we consider the vertical forces, we can able to equalize the forces which is directed upward to the forces directed downward. So the 600 should be equal to R plus P sin 45. Right? So if we consider the horizontal forces, then it should be equal P cos 45. Right? So now we have to find the value of P. Right. On the other hand, now let's consider this one as the first equation. This one as the second equation. But go through the question very carefully. That's mean you have to consider, you have to relate the coefficient of static friction too. So coefficient of static friction, the related equation should be equal to F equal mu R, isn't it? Right. So first of all, we have, so if you are going to substitute this equation by using the obtained expression, so this P cos 45 should be substitute for F, and we have to we are aware of the value of mu, and we have to substitute the value for R. So that's mean if I subject the R, oh, this can be further elaborated as P sin 45 mean 1 over root 2. That's mean R can be represented as 100 minus P over root 2. So this is the value of R. Okay, guys, let's consider this equation as a third one. So if I substitute the relevance values for this third equation, so this one, F equal mu r can be substituted as if P equals 45 as if mu is 0.5, that's mean half. R mean 100 minus P over root 2. See, very clear, right? Then P sine for this P cos 45 means P 1 over root 2 equal half. So if I multiply these two terms inside the bracket is multiplied by from the half, then it can be obtained as 300 minus P over root 2. Right. So let's take this term into the opposite side. So we can be able to subject the P. Right. Then P over root 2 plus P over 2 root 2. So if I consider the common denominator as 2 root 2, this one should be multiplied by 2 as well as the P. So it should be 2P plus P. Then guys, so we can be able to assume that it's equal to 300. So if I consider the common denominator as 2 root 2, it should be written as 3P equal 300. Then P equal to 200 root 2. So guys, this is the answer for the P at this instant. Right. So in the next part of this question, if theta is changed, by keeping P constant, then the maximum and minimum friction force acting on the object, right? So now, what is the related equation with the friction? That is, according to the second equation, F equal friction force equal to P cos 45. Now they mentioned that P remain at constant. So then, guys, so let's assume that this angle as theta. So if I have to substitute this equation instead of 45, I'm substituting as theta, right? So then it should be P cos theta, isn't it? Right. So now what I'm going to do is I'm trying to break in some relationship between the theta and the friction force, right? So if the P is constant, we can be able to consider that F proportionate to cos theta, right? So guys, you know that when theta is increased from 0 to 90, when theta is increased from 0 to 90, cos theta is getting decreased because cos 0 is equal to 1, cos 90 equal to 0. That's the relationship, right? So that's why when the theta is increased, cos theta, what happened to cos theta? It's getting decreased. So according to this equation, we can able to build up some relationship that theta when decrease, cos theta decrease. According to this equation, friction force should be also decreased. Hence, the minimum friction force should be at when the theta is maximum, that is 90, and maximum friction force is obtained when the theta is minimum. The minimum value for theta is equal. So these are the two values, right? So guys, it's better to you should have to able to build up a relationship by looking at the equations, right? Correct. Okay, so in the question mention the reason why the value of force value of force uh that's the issue in the equations, right? So just skip it. So let's move on to the key part of this question. Find the value of P that should be applied vertically to move the object vertically upward from the plane of the surface, right? So guys, now you are asking to find the minimum force that should apply on the object to uh, slightly move upward. So that's mean what are the forces exerting on this object? Like these are the forces which is exerting on the vertical direction. But when the object slightly raised from ground, the contact between the ground and the box is lost. So therefore, its R becomes 0. So that's mean P minimum should be equal to mg. So it should be equal to 300. That's the weight of this object. Okay. Right. Right. So this is the second. So this is the answer for the question. Right. The third question. Three trolleys A, B, and C of mass 1, 1, and 8 respectively are kept at rest on a frictional horizontal rails. Consider that all collisions taking place to be elastic. Right. As shown in the figure, the trolley A is projected with the velocity v towards the trolley B. Assume that the velocities of A and B are VA and VB after the collision. Obtain an expression by considering the momentum conservation law. Right. So guys, now these collisions can be considered as elastic collisions, right? So now let's consider this one as the A of the A trolley, and it is moving with the V velocity. Initially, the P object or B trolley is at rest, but it is also having the same mass. So then after the collision, let's assume that velocity of the A object or A trolley, velocity of the A trolley as VA, velocity of the B trolley as VB. Now these two trolleys are identical, right? And the other thing is these collisions are elastic. So guys, you should remember that if there's the elastic collision between the identical object, what happened? The velocities can be changed, right? That's mean this object is at rest. A object is moving at v velocity. So then ultimate result is then after collision, VA, so velocity of the A object take the velocity of initial V velocity. So that's mean it's equal to 0. Then the velocity of the B is take place the velocity of the A at the initially. So these should be the velocity, right? So you don't go for a simplification, but you should have to idea in this theoretical point. Okay. All right. So obtain an expression by considering, right. So guys, I made a mistake, right? So initially you are asking about, you asked to obtain a relationship, isn't it? Okay, now let's apply the momentum conservation. So I mentioned, I thought whether they are asking about the final conclusion, but they are asking about the applying the momentum conservation law, right? So if it is, we know that the initial momentum, that is in 1 into V equal to 1 into VA plus 1 into VB. So the relationship equal to VA, V equal VA plus VB. So let's consider this one as the first equation. Okay, in the second question, if the sum of the kinetic energy is conserved before and after the collision, it is defined as the elastic solution. Obtain an expression by considering the kinetic energy conservation. Okay. Now let's consider, let's apply the kinetic energy conservation before the collision and after the collision. Then half into V squared equal half into 1 into V A squared plus half into 1 to VB squared. So if I cancel the half, then we can able to obtain then V squared equal VA squared plus VB squared. Let's consider this one as the second equation. Hence, in the third question, hence show that when the trolley A and collide with B, A becomes stationary and B takes off with a velocity of V. Right. So what I'm going to do is I'm considering that VA equal V minus VB. So let's apply this equation for the second one. Let's apply value of VA into the second equation. Here is equal to V squared. Instead of VA, I'm going to substitute this one. That is V minus VB square plus VB square. Then V squared equal V squared minus V2 VB plus VB squared plus VB squared. Right. So what happened? These two can be cancelled, and 0 equal minus 2V plus 2V squared. Right. So this, let's take consider this one as the current equation. Okay, so let's if I further simplify, I'm taking this term into the opposite direction. So 2V VB equal to VB squared. Then these two cancel. Hence VB equal V. So if I substitute the obtained value for the third equation, so then VA equal V minus VB now. So we have derived that the value of VP as V. So if I subtract V from V, so answer should be the 0. Right. So this is the value of VA and VB. Right. So in the fourth part, consider the collision between B and C trolleys. Obtain the velocities of B and C trolleys after the collision. Right. So now what happened is before the collision, the B object is moving with V velocity, and C object, that is 2 kilogram, sorry, 0.5 kilogram is at rest. Let's assume that the velocities after the collision as V1 and V2 right. Now we have to apply the because each collision can be considered as elastic, isn't it? Because it is mentioned in the introduction of this question. Now, first of all, let's apply the momentum conservation law. Then it should be 1 into V equal 1 into V1 plus 0.5 into V2. Then V equal V1 plus V2 half. Isn't it? So I'm converting 0.5 into half. So let's consider this one as the first equation. So guys, if it is the elastic solution, we can be able to apply the kinetic energy conservation law. If I apply the kinetic energy conservation law, then half into 1 V square equal half into 1 V1 square plus half into half, because the weight of the C object is also 0.5, that's mean half V2 square. Right? If I cancel the 2 from each equation, from each term, then V squared equal V1 squared plus V2 squared over 2. Right. So what I'm going to do is I'm considering the, so let's consider an equation for V1 using this equation. This that's mean if I subject the V1, then it can be written as V minus V2 over 2. So let's consider this one as a third one. So guys, let's substitute the V1 value. That's it. It is obtained at the T equation, third equation for the second equation. Hence, V squared equal V1 mean V minus V2 over 2 square plus V2 square over 2. Then V squared V2 plus V2 square over 4 plus V2 square over 2. Isn't it? Right. So these V2 square can be cancelled easily. So if I take this V2 into the opposite direction, or it's converted to positive, then V2 squared over 5. So this expression can be equalized. Then, if I further simplify, so I can able to obtain that value for V2 as 3V over 4V over 3. So this is the value of V2. Then if I subject the V2 value for the first equation, then V equal V1 plus, instead of V2, I can able to substitute 4V over 3, but it should be divided from 2. Then V equal V1 plus 2V over 3. Then V1 equal V over 3. So this is the answer for V1, right? So likewise, you have to be familiar with this kind of calculation, students, right? In the fourth question, figure shows the displacement time curve of an object which moves in a straight line on a horizontal table. Mass of the object is 0.5 kilogram. Find the initial and the final velocities of the object. Right. So first of all, clear this graph. So it is the x-axis, y-axis represent the distance, x-axis represent the time. So this value should be 50. This is 150. This point should be equal to minus 50. So the other values, so this should be 10. This one is equal to 25. Right. So if I explain this graph, guys, so you can able to figure out that the gradient of this part is positive and constant. This part is positive, sorry, it's negative and constant. So the relevant graph, velocity graph should be a kind of this, right? Positively constant and then negatively constant, right? Okay. Find the initial and final velocities of the object, right? So that's mean by considering the gradient of this part, we can be able to consider the velocities at this point. Let's consider it as v1. So v1, you know that v1 is equal to gradient of this graph. So v1 can be obtained by delta y over delta x. Delta x equal to delta y equal to 100 over 10. So the velocity should be 10 ms minus 1. So v2, let's mean the velocity in the second half of this graph can be obtained by delta y can be equalized as 150 plus 50 means 200. Delta x means 35, this is 10, and it should be equal to 25. So that's mean it should be equal to 8. Second one, draw the corresponding velocity time curve for the whole journey of the object, right? So guys, this should be the velocity time graph. Determine the total distance traveled by this object, right? So the distance can be obtained by using this velocity time graph by considering the area of this graph. So this should be 10. This should be 10. This should be 35, right? So in the third question, we have to consider the area. So this area can be obtained by 10 into 10 plus, sorry. So this can be obtained by minus 8 multiplied by from 25. So it should be 100 minus 200. So the answer should be the minus 100 meters. Right. So guys, the initial point is 50 and the final point is minus 50. So that's mean the displacement of this object can be considered as 100 by looking at the given diagram, but it also can be obtained considering the area of the velocity time graph. See, so this is the A part. This is the A part. This is the B part of the second question. In the C part, explain what happened to the motion of the object at t seconds, at t 10 seconds. Give practical exam where the similar changes that occur at. Alright. Guys, what happened? Direction of the motion is changed. Direction of the motion is changed. Right. So this can be happen when throwing a ball in vertical direction, vertically upward direction. So what happened? At the highest point is change the direction of the motion, right? So this can be considered as an example. Right. In the third part of this question, suppose that object experience constant frictional force exerted by the cable after 35 seconds and it come to rest in further 2 seconds. Find what is the magnitude of the frictional force acting on the object. Right. So that's been at the 35 seconds, object The velocity of the object is 8, isn't it? And it is come to the rest within 2 seconds. Right? So we can able to find the acceleration due to this frictional force, isn't it? Let's apply this equation. E equal u plus at. V equals 0, u means 8. A into 2. So A minus 8 equal to 2A. Then A equal to minus 4 ms minus 2. So the force can be obtained by using this equation. M is equal to 0.5. A is equal to 4. That means the frictional force exerted on the object is Stokes limited. So this is the A part of this question. And B part. Calculate the coefficient of friction between the object and the table, right? So this friction, this resistive force is exerted due to friction. So then by using this equation, we can able to obtain the coefficient of friction. So the F should be 2. We don't have any idea about mu, but we can be able to obtain that. Now this object is moving in a horizontal direction, horizontal surface. Then what are the force acting on this object or vertically? So this is the direction of the force, right? So R should be equal to mg. So then it can be considered as 5. So the u equal 2 over 5. It is a unit plus quantity, right? Okay. Now in the fourth question, let's assume that the front face of a bus is a vertical plate of rectangular shape of area A. The vehicle is moving with a constant speed v on a horizontal path in still air as shown in the figure. Now the air remains at rest. Assume that the air molecules collide with the front surface of the car at a speed v perpendicular to the bus, and after the collision, air molecules bounce to the opposite direction with the same speed relative to the bus. Right. First one. If delta T is the change in the linear momentum of an air molecule in collision, the time it takes as delta T, the mean balance force acting on the air molecule by the particle is F. What is the relationship between these three quantities, right? So we know that if T equal to momentum difference, right? So then it can be represented as delta T over delta T. So this is the base equation for this question, right? If T equal momentum difference can be represented as this. But here, momentum difference is represented as delta P. So that's why I substitute this delta P. State the law of motion used for this. Right. So this is we use the Newton's second law. So the base equation is Newton's second law. We use Newton's second law. In the second question, obtain an expression for the change in linear momentum when air molecule mass of m collides with v velocity with the front surface and bounce back with the same velocity as mentioned in the above. Also indicate its direction with an arrow. Right. So according to the question, when the bus is moving towards this direction, air molecules, now let's assume the bus is moving towards this direction. Initially, air molecules collide with the bus with the v velocity, and it is bounced back to the opposite direction with the same velocity. So now what I'm going to do is I'm going to take in the momentum difference, right? So momentum difference can be obtained by final momentum minus initial momentum. So final momentum direct towards the opposite direction. So that's means mp minus initial momentum should be also equal to mp, but the direction should be opposite. But here the arrow sign position in opposite direction. So we have to convert this into both arrows into same direction in order to make the simplification, right? So that's why I'm changing the direction of this arrow. Ultimately, what happened is sign convert into positive. So the total momentum difference should be 2mv, right? So in the third part of this question, the below graph exhibits the variation of the unbalanced force exerted by the surface on the air molecules varies with time. How to find the impulse acting on the air molecules from the graph? Right. So you know that area of force time graph represent momentum difference. On the other hand, it can be mentioned as impulse exerted on the object. So the how to find the impulse acting on the object by considering the area of the graph. This is A and the B. Determine an expression maximum impulsive force acting on the air molecules causing by the graph and expressed obtained in the second question. Right. So guys, the impulse force or the momentum difference can be obtained by considering the area of this graph. So that is half Fm into delta T. So this is the momentum difference of the object. Previously, we have obtained that momentum difference as delta P. So this equation, this expression also represents the momentum difference, right? That's mean according to the equation, half Fm delta T can be equal to the 2mv. Hence, we have been able to obtain an expression for Fm as 4mv over delta T. In the fourth question, write an expression for the mass of air collide with the surface of the bus in unit time. Assume that the density of air is T, right? So you know that the mass which is collide with the mass which is collide with the surface in unit time can be obtained as using this equation, right? So this equation should be keep in mind. So A mean vector area, B mean velocity, rho mean density. So it should be substituted as D. So this is the answer. Derive an expression for mean air resistant force caused by the collision of air molecules on the front surface of the bus using the relation in above or other method, right? So guys, the resistive force exerted by the molecules of air can be obtained by using this equation, isn't it? Right? So it's equal mv. Right. So m f into t equal to delta p, no? So the delta p equal to mv. Right. So it can be obtained as, so this is the equation which is derived the force, right? But you know that you should know that m over t can be given as by using this equation. So this is, guys, keep in mind that this is the mass of the air molecule which is collide with the surface in unit time. So m over, instead of m over 2, we can able to substitute it as ABD. So the force should be written 2 into ABB into B. So this is the equation 5.